Today we are very interested to investigate the concept of mole. But before we investigate the concept of mole, I'd like you to think of this phrase: actual over standard. It can be actual mass over standard mass. It could be actual number of particles over standard number of particles. Okay, when we say standard, we are implying something, right? Let's go through the text. You see, this Avogadro's constant, the scientist has set some kind of stuff. You know that 1 dozen will have 12, let's say 1 dozen of flowers will have 12 stalks of flowers. 1 dozen of ping pong balls will have 12 ping pong balls. So they use 1 mole to represent 6.02 times 10 power of 23. So the entity can be atoms, molecules, or ions. The example calculation, let's come back to this slide later. So let's look at relative mass and actual mass. Now, I want you to imagine one single atom. The relative mass is 12. When you compare this with hydrogen, hydrogen is just 1. The mass is 1. Carbon will have 12, means carbon is 12 times heavier. And then you have 1 mole of carbon atoms. See, just now we have only 1 piece. Now we have thousands and millions and billions of pieces of atoms. If they come together, they will have exactly 12 grams. 1 oxygen atom, just 1, it has relative mass of 16. 1 mole of oxygen atoms, just now 1, now a lot, it would have 6.02 times 10 power of 23 oxygen atoms, has 16 grams. 1 magnesium atom has relative mass of 24. That's only 1 magnesium. But what if 1 mole of magnesium atoms? That is a lot of magnesium atoms. You will have 6.02 times 10 power of 23 magnesium atoms, and it will have 24 grams. 1 chlorine atom has relative mass of 35.5. That's 1. But if you have 1 mole, a lot of chlorine atoms, 6.02 times 10 power 23 chlorine atoms, you will have exactly 35.5 grams. 1 bromine atom, just 1, it has relative mass of 80. 1 mole, that's a lot, of bromine atoms would have 80 grams. 1 nitrogen atom has relative mass of 14. If you have 1 mole, which is thousands and millions and billions of nitrogen atoms, it would have 14 grams. So as we go through a lot of examples, we get some idea. Okay, 1 mole always gives you the standard number and always gives you the standard mass. Okay, so number of moles, small n, number of particles, big N, Avogadro's number, Na, actual mass in grams, small m, mass of 1 mole of substance, molar mass. So you have actual over standard, again, number of mole, actual mass over standard mass. You can relate this with the actual mass in grams, remember it's in grams, over the relative mass. The relative mass, we should call it molar mass. Okay, actual over standard again. Number of mole can also be actual number of substance over standard number of substance, which is big N over N A, Avogadro's number. So the interconnections will be, if you want to find the number of mole, is always actual over standard, mass over molar mass, or number of particles, actual number of particles over standard number of particles. Alright.